Hello. Now we shall talk about Taylor polynomials. The Taylor polynomials are the partial sums of the Taylor series. Here I have written a formula. This is called the Taylor's formula, where the function is written as Taylor polynomial of order n plus the remainder. Shortly, we write it this way: fx equals tnx plus Rnx. The Taylor polynomials are used to approximate the function, among other things. And the difference between the function and the Taylor polynomial of order n, this is absolute value of the remainder. And in many cases we can estimate this. In many cases this becomes small. It becomes small either when n becomes large or when x gets closer to this point A, where the Taylor polynomial is centered. So I want to write this down. This is small when n is large, or when x minus a is small. This is something not written very well, something happening with the screen. Let's write this again. So either this is small or n is large. Remember, we had estimate what remember if the nth plus first derivative of the function is less or equal to m, a constant, then the remainder is less or equal to this constant m over m plus 1 factorial times x minus a power m plus 1. So you can see that when you make x minus a small, remainder becomes small, or you can keep x fixed and increase n. You have n factorial in the denominator, so this is getting small again. Now, first we have to practice computing some Taylor polynomials, and I shall do some examples. Here is my first example. Given is the function sine x, and we want to find the Taylor polynomial of order 3 centered at a equals pi over 6. So we have to write this polynomial. First I shall write this in general form. Taylor polynomial of order 3x, this is f a plus f prime a when it's centered at a. Here 1 factorial, this is for symmetry. X minus a first power. Then we have x second at this a over 2 factorial. X minus a squared. And also plus the third derivative at a, 3 factorial, x minus a cubed. This is the third Taylor polynomial centered at a for any function. And now we have to take a to be pi over 6 and f to be sine x. So we have to compute sine pi over 6. So that's f of a. This will be now f pi over 6. Will be sine pi over 6. And we know that this is 1/2. Then f prime a. F prime here is cosine x. F prime pi over 6 will be cosine pi over 6. This is root of 3 over 2. Moving to the second derivative. F second will be negative sine x. F second pi over 6. will be negative 1/2. And now we also need the third derivative. The third derivative is negative cosine x. Third derivative pi over 6 will be negative root of 3 over 2. And now we just have to substitute this in our general formula. So the third Taylor polynomial for this function will be f of a. This is sine pi over 6. This will be 1/2. Then f prime is root of 3 over 2. And we have 1 over 1 factorial x minus pi over 6, like that, first power. I'm just writing 1 factorial to remind you the formula. Then we have the second derivative, minus 1/2. We have 1 over 2 factorial and x minus pi over 6 squared. Then also we have minus root of 3 over 2. Third derivative of pi over 6. 1 over 3 factorial x minus pi over 6 cubed. And now we have to simplify this, of course. The third Taylor polynomial here will be 1/2. 1 factorial is just 1, so I'm writing root of 3 over 2 times x minus pi over 6. It stays like that. Then we have 1 over 2 factorial, that's 1/2. 2 factorial is 2. Another 1/2, so this will be minus 1/4 x minus pi over 6 squared. 3 factorial, that's 6. 6 times 2 is 12, so we have minus root of 3 over 12 x minus pi over 6 cubed. And this is our required Taylor polynomial. Another example. Let's take the function fx, which is x cosine x. And we want to find the third Taylor polynomial centered at 0. So we just have to take the Maclaurin series for the cosine, which is very well known, and then take the partial sum, because this is what we required, centered at 0. That's the Maclaurin series, and we know for the cosine how is this. But this x in front, we shall multiply by this, the Maclaurin series. We don't have to find derivatives here, although we can do it with the derivatives. But here is the short way to do it. So start from this expansion. Cosine x is 1 minus x squared over 2 factorial plus x fourth power 4 factorial and so on. We don't have to go further because we already have here Taylor polynomial fourth order, and for the third order will be just the first two terms. Now if we multiply this by x, we get x cosine x will be x minus x cubed over 2 plus x fifth power 4 factorial, which is 24, plus and so on. And because we want the third degree polynomial, it's just this part here. That's it. Third Taylor polynomial is this, up to power 3. And that's all we have to do.